Start discuss about the second unit, unit 2. Talks about elementary combinatorics. The first unit was fundamentals. Now we want to talk about elementary combinatorics. This is the unit title. Where we need to wait for your friends. How many of you are there? Only 35. What happened to all of you? The remaining. Okay. They are joining. They should be on time. This is the first class. They should not miss this actually for this unit. So till that, some of you may ask me any doubts or suggestions you can give me. When are you people are coming to the campus? On next week or what? When do you come?
16, sir.
16. So the next week we do not have a class. We have to reschedule this. 13, 14 you said, right? 13, 14, the faculty coordinator sent a message.
Yes, sir. 13, 14, 15.
No classes. Then 16 you will be, when do you report actually that particular day of reporting?
16.
On 16th morning, if you report, then that also in that day also we do not have a class. I think so. Some of you may reach gate. So this is the first time you are visiting the campus. Is it so? Or you came already? This is the first time. Okay. So on 16th, if you are reporting, then they will be asking you to take a COVID test or some kind of registration, and they will be allotting room. You may be busy in that. So next week till Thursday, we do not have class. And so you have to find out some other time. So how many days quarantine they suggested? 5 days or what? Okay. But once you reach the campus, if the reporting is completed, then we can continue online classes. For that 1 week quarantine time. That will be informed by the institution, of course. Okay. Whether we shall we proceed? It's already 5 minutes late. So here in elementary combinatorics, we want to talk about permutation combinations. Roughly, if I tell you a job, in how many ways you can do it? Say you people are in first year or in second year, I want to select 3 students for NSS. In how many ways I can do it? 3 students from the second year students. I will be having some condition. 2 students must be boys. 1 student from the set of girls. And 1 student from among the 3. 1 boy must be from computer science. Another boy must be from ECE. That girl must be from mechanical engineering. These kind of conditions I give you. Then I am asking how many ways we can do this selection. The selection is my job. I want to select with these conditions. How many possibilities I have? Instead of doing it manually by trial and error, I want some mathematical techniques. Without doing the trial and error technique, I shall do it with pen and paper. So that's what we more general versions are called as permutations, combinations. Let us come to that. First, we need counting techniques. Basics of counting we need. I shall tell you two rules, basics of counting. Based on the two rules, sometimes by avoiding these two rules also, we can compute how many ways a job can be done. I shall give you two situations. Probably we have seen this already. I'm not sure whether in this class or the other class, because it is just common sense. One example I'll give you. Okay. Just examples are motivating examples. Okay. First one. Suppose if you have 3 math books, 5 CSE books, and 10 what subject we are studying already, then some other subject. Only 2 things you are studying, right? Math books, CSE books, and some other literature books. Say this is example number. Okay. I need math book or CSE book. I want to choose. This is my question. In how many ways I can do this selection? In how many ways I can choose a math book or a CSE book? What do you think?
So 3C1 plus 5C1.
What do you mean by 3C1 plus 5C1? Make it simple. You are right. But I don't know that C meaning. Imagine that I'm a 10th class student. I already said common sense. You are right, of course, but make it simple. Just I'm giving in your hand, then you are looking at them. What is the value of 3C1?
3, sir. 3 plus 5.
3 plus 5 possibilities are there for the selection. Is it okay? Instead of 5, let me use V. We want to select a math book or a computer science book. There are 3 plus 5 possibilities for that selection. Okay. Instead of this, let me write 3 plus 5 ways. This is okay. Another example. Another example, I am having a bookshelf like this. This is my bookshelf. Okay. Only 2 books can be kept. One book here, another book here. Only 2 places. We want to keep one math book here and then another CSE book. Yeah, math book in first place and a CSE book. in this place. In how many ways this can be arranged?
15.
How did you say that? Here 3 mass book. First I will keep one mass book, M1. CSE book can be kept in any of these. 5 ways are there. 1 time 5. Again for M2 one another 5 is appearing. For M3, so with this reasoning or with this basic understanding, you are having 3 possibilities for this first place and 5 possibilities for the second place. These many ways are there for this arrangement. Both are selections, but this is a special selection. First place always for a mass book, second place always for a CSE book. Okay. So 2 rules we have used. Here addition in the first example. In the second situation, we have used multiplication. Meaning this R symbol, we shall write in red color, that becomes plus. This and symbol, connective, we have used already. This connective symbol becomes multiplication. Okay. So this we call as sum rule. What else we call this? Product rule or multiplication rule. We are making a product here. Based on logic, you conclude that. Now we want to write down that as a rule. Hi, someone tell me whether we have seen this situation already. Yes or no? This kind of say
Yes. Yes, sir.
we have seen that already. Then we can go for a few problems. Before that, let me write them down. We want to count the event. The event here is selecting a book. This book or that book. Here, in the second situation, instead of keep, we shall say select. Yeah, that also is fine. So this R becomes addition. That we shall write further. Here the event is selection of book. Some rule for counting events. Counting how many events are possible or how many ways that can be done. For counting events. Okay. If E1, E2, En are mutually exclusive events. Mutually exclusive refers they cannot happen simultaneously. Imagine computer science book, maths book, and literature book, E1, E2, En are mutually exclusive. One prevents the other. That's what we mean by this mutually exclusive. If it is a CSE book, It cannot be a math book, it cannot be a literature book. That's what I mentioned already. Practically, it may be different, but in our example, we mentioned it. Even are mutually exclusive events. And one more thing we are having. E1 can happen in even number of ways. First event, that's what we mentioned as 10 literature books. Not only this, we are having E2 can happen in E2 number of ways, and in that way En can happen. I'm just changing it. Second event can happen in this small E1, small E2, small En are referring numbers. Capital E1, capital E2 are referring the event number. Then we have the conclusion. If this is the case, then E1 or E2 or E3 or E1 or E2 or any one of them only we are checking can happen in. Can somebody complete? Can happen in how many ways this can be done? Earlier we were having, maybe let me make things smaller. Earlier we were having just only two events. E1 refers selecting a math book, or E2 refers selecting a CSE book. Here I am introducing many numbers, many events, E1, E2, En. This can be happening in only these many ways. E1 plus E2 plus wherever R came, I am writing these many ways. Then E1 this can happen in even number of ways. That's it. This we have already applied, just I am writing down now. Is it okay? We shall do few problems today for implementing the sum rule for counting events. Similar sum rule for probability is available. Similar sum rule for counting number of elements in a set, in set theory notation also is available. Here we need how many ways a job can be done. Our job is selection. Just let us keep that selection. Particular selection that may be arranged selection or unarranged selection. Then we shall write product rule. Product rule again for counting events. I'm saying simply counting events, that means in how many ways a particular event can happen. The same thing we shall write, but this time it is a product rule. Here we have one thing, like our example here, first box is filled, then second box is filled. There is a sequence of events. First we are selecting a math book and then we are selecting a CSE book. That kind of sequence of events, maybe let me write down here, sequence of events. Don't forget that, okay? Earlier we were having things simultaneously. Product rule for counting events. If E1, E2, En are, here we are writing E1, E2, En are mutually exclusive. It need not be mutually exclusive here. Only thing is that maybe we shall erase all these. We have if events here is referring selection. E1, E2, En can happen in the small number of ways. Okay, can happen in E1, E2, En number of ways respectively. It is done. Not only that, we have one other thing. Then E1, maybe let me write down the sequence of events. If this is our hypothesis, then the sequence of events E1 first, it is happening E1 first, then E2. Let me write down and the sequence of events E1 and then E2 and then E3, finally En. This can happen in this multiplied number of ways. Number of ways, that's it. We have done an example already. Now we are writing down the result. Maybe we can write a comma for splitting them. E1, then E2, and then E3, finally En can happen in the sequence of events. The entire thing can happen in this many number of ways. This is what with only 2 events we have done. First 3 possibilities and then 5 possibilities. So we are multiplying the possibilities. 15 ways are there. Is it okay? Are you people are following? If you have any questions, you can ask me. If you need more examples, we can give. Someone tell me, is it okay? Do you follow that? 2 rules we have seen, that's all. Someone speak.
Yes, sir.
Let us do some problems. Let us do some problems. Suppose if I have a few problems, let me write down. I am having 2 dice. Okay. One red color, one blue color. 2 distinguishable dice. Let me write that out. 2 distinguishable. You can differentiate. I am having. Like this I have. I am throwing them together. I need the total of the recorded results. 4 or 8. In how many ways this can be done? That's my question. 2 dice are thrown. I need some 4 or 8. Both dice are in different color so that you can realize which die gives you which number. How many ways this can be done?
8.
8 ways you can have. For Question is not yet completed in terms of English. Okay, I'm not writing the complete sentences. Just we shall do problems. Then, if possible, I shall enhance the question in terms of English. Now we want how many ways this can be done. So first I need for some 4. For some 4, what do we need? We need first die 1, second die 3. And this is one possibility. First die 3, second die 1. This is another possibility. Both dice are 2. This is one possibility. Therefore, 3 ways or 3 possibilities I have for getting some 4. For some 8, this is what the person answered has done without writing. For some 8, I need 1,7. I cannot write. You see, no possible. 7 is not there. I am having 2,6 or 6,2 or 3,5. Let me do something in terms of a pattern. Okay, 2,6, 3,5, 4,4, 5,3, then 6,2. Therefore, getting 8 as a summation, I have 5 number of ways. Therefore, if you ask me number of ways, some 4 or 8 can be obtained in 3 plus 5 number of ways. That's it. That's what he replied. Take a minute for understanding this. Suppose if the same problem, if I have indistinguishable dice, just only 2 dice, that's all. Another problem. That also matters. Okay. I'm simply saying that 2 dice I have. No different color. Just I'm throwing 2 dice. That's all. I need some 4 or 8. In how many ways I can obtain some 4 or 8? That's my question. For some 4, I will be having only these 2 possibilities. For some 8, I will not know whether 2,6 or 6,2 is obtained. Both are very similar, same color die. Then I will be having only these many ways. Only this is a possibility. So 2 ways for this and 3 ways for this. So 5 ways are there. That's it. You cannot do it mechanically. Even though you are using a rule, you should apply some reasoning also. Whereas here we have used just addition rule only. Again, one more problem. The question is, in how many ways we can have even sum? In how many ways we can have even sum? Can somebody try that in this problem? In how many ways we can get even sum? Two distinguishable dice are thrown. The sum is recorded. This is a complete sentence. Okay. How many ways this can be done?
22, sir.
22. How did you do it?
Sir, we'll get two for 2, 4, 6, 8, 10, 12. That's it, sir. For them, we need to
2,
find
4, 6, 8, 10, 12 also is okay, no?
Yes, sir. 6 plus 6.
12. So the sum must be the sum. Okay. We need the sum as this or that. Okay. So this can be done in or simply this can be obtained in how many number of ways? Exactly below I will be writing. Okay. 2 can be obtained in 1 comma 1. That's all. For distinguishable dice, both are 1. Is it okay? Only one possibility for getting 2. Is it fine? For getting 4, how many possibilities? 1, 3, 3, 1, 2, 2. Imagine two different size dice and choose the numbers. 1, 3, then 3, 1, 2, 2. So 3 ways are there. What about 6? How many ways 6 can be obtained? 1, 5, 5, 1, 2, 3, 2, 4, 2, 4, 4, 2, 3, 3. 5 ways are there. Okay. What about 8? How many ways it can be obtained? Okay. 10, how many ways it can be obtained? Okay. 12, only one possibility. So 18 ways are there. That's it. These many number of ways. Is it okay? You see, all of you please cross check whether the computation is okay. If you don't understand or if you find any minor mistakes, you just inform us. Okay. For the other indistinguishable dice also you can check a similar problem. Now let us go for another thing. Let us take a number plate problem. Suppose if you have a number plate, another problem. Okay. Vehicle number plates I am having. I have 3 English letters followed by 4 digits. This is the format of that number plates. How many number plates can be developed, can be written? That's my question. If repetition of letters and digits are allowed. You can use again and again. If you have difficulty in understanding, you just make like this. First 3 boxes are for letters. Then the next 4 boxes are for numbers. Somebody has typed a message. Anything? 114 they are saying. How did you say that? Explain please. 114. Again 114 somebody is saying.
Sir, for first box, there are 26 ways, sir.
First box there are 26 ways. Okay, let me write down here. Okay. Okay.
Plus second box 26. Plus third box 26.
Okay. Look at this picture. You need letters here in these places. And then numbers here. I have not, you are using plus symbol. I am not using R anywhere. Did you follow that? Plus symbol will come only if I use this or that. Look at the number plates. First place, any letter can come. And second place, any letter can come. I'll do it.
Sir, then sorry, sir. 26 into 26 into 20.
First place, 26 letters are possible. And see, I am speaking and, but I am writing the symbol. The mathematics plays a role here. First place 26 and second place 26 possibilities. Third place 26 possibilities. And this place, fourth place is a digit. It may be 0 to 9. So there are total 10 numbers are there. Again 10 numbers, again 10 numbers, again 10 numbers. So what do we have actually? We are having 26 power 3 multiplying. Oh, let it be there so that you can understand. You can simplify this further, that's it. I did not allow any restriction. Simply, I kept everything free. You see, suppose if somebody comes and write, sir, this is the number plate. I'll agree. Yes, that is a number plate. It is also possible. Because no restrictions. I never mentioned anything at all. Now, I want to slightly modify that. Another question. If only letters can be repeated, English letters, how many possibilities are there? Only letters I can repeat, meaning numbers I cannot repeat. How many possibilities for first box? Quick.
26.
26, very good. You see, we cannot solve a problem at a stretch. Step by step we will do. First box has 26 possibilities. Second box, why?
26.
26 or 25? If, no, I'm saying if only letters can be repeated. This only refers, numbers cannot be repeated. Okay, 26 multiplying 26. Third box, again 26. Fourth box, 10 numbers can be written. Fifth box,
9.
9 numbers, then 8 numbers, then 7 numbers. That's all. Because they cannot be repeated, so I'm reducing one possibility for them. What must be the next question? Say something there. Slightly modify your number plate restriction. Then we will try.
Only numbers can be repeated.
Okay, if only what did we say? Digits we mentioned, so only digits can be repeated. What does it mean? Letters cannot be repeated. First box has 26 letters, the second box 25 letters, third box 24 letters. Numbers can be repeated, so I am just writing all of them are 10. Any other possibility we left? No repetition is allowed. "26, 25, 24" because I cannot repeat the letters. 10, 9, 8, 7. Is it okay? Nothing can be repeated, so I am reducing the possibilities for letters as well as numbers. Slightly, we will modify this problem, okay? Are you following the last problem? Another problem. These are counting techniques. We need better version of this. These are very simple intentionally. Different number plates I want to prepare. Okay. Number plates, they can be involved with vehicle number plates. Let me write down. With the condition that 1 or 2 or 3 letters followed by 4 digits. This is my number plate. There are 3 cases. Look at this. How many number plates I can generate? How many number plates I can generate? How many number plates are possible? How many number plates are possible? First possibility, 1 letter and 4 digits. This is one possibility. Or 2 letters and how many digits? Again 4 digits. This is one possibility. Or another possibility is 3 letters and 4 digits. That's it. If we write or if you count the number of A's, 1 letter is English letter, of course, 26 possibilities. And 4 digits, this. Or this addition rule. Okay, 2 letters we have this, and again 4 digits. Or 3 letters and 4 digits again. Here I have allowed any kind of repetition. Since I did not mention a restriction, you are free to use. So what do we have actually? We have 26 into 10 power 4 plus 26 square into 10 power 4 plus 26 cube into 10 power 4. You can simplify this further. Therefore, number plates are possible. What is the speciality of this example? We have used both rules. Multiplication rule, that's what we mentioned as product rule, and also addition rule. We have used both. One more problem we shall try. How many 2-digit or 3-digit numbers are possible? You will be solving this. How many 2-digit or 3-digit numbers can be formed using these numbers, using the digits 1, 3. I am giving numbers also 4, 5, 6, 8, 9. This many numbers. If no repetition is allowed, I am giving a specific problem. Can somebody try for this? Only you are allowed to use only the digits I mentioned 1, 3, 4, 5, 6, 8, 9. Only they are allowed. Can somebody tell me what is this? Any idea about this? How many 2-digit numbers are possible? Tell me that first. How many? 42. How did you say that?
7 into 6.
7 into 6. Okay, let me draw like this. Okay. This is 2-digit number. So you are saying 7 into 6 possibilities. Okay. 7 into 6. Okay. Then how many 3-digit numbers are possible?
210.
210. Okay. This is 7 into 6. Here you are writing 765. So here you are multiplying all of them. So here this or that. For that you are using one addition also. So this is 42. This is 210. That's it. 252 numbers are possible. Usually we write 7 into 6 plus 7 into 6 into 5. That's it. This dot refers multiplication. Center dot this is. It is not 2.5. 2.5 is different from 2 center dot 5. You could see this in textbooks. This dot on the bottom place is decimal. The dot on the center point is multiplication. That's it. Here also you have used multiplication rule and addition rule. With that, we shall stop today. We shall do few more problems in the next class. Do you have any doubts? Then we shall stop at this point. Okay, bye. Thank you. Well, I shall send the transcript after 11 o'clock. I have another class. After that, I'll send.